Okay, good morning, all of you. Am I audible? Can anyone please confirm? Okay, let me change settings. Okay, 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 guys. So we can discuss stateful set communication process. We can discuss in today. Okay, what is stateful set? How both, pods can communicate to specific only zero pods, master, replica, and all. We can discuss. Okay, let me check mine once. This is, yeah, okay, 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 that's okay. Process talk. Okay, that's okay. Okay, let's go to the cluster now. Okay, let's connect the client mission now. Okay, okay, two nodes are running fine. So we already discussed here somewhere, I think. Yeah. Hmm. So guys, in this concept we already discussed, if you develop any project on Kubernetes, so we can, if it is a full stack, front end pods we can deploy as usual, like a Docker image. We can build a Docker image, we can deploy front end pods, and we can enable horizontal pod autoscaler for the front end pods, and whatever you can deploy, same backend also we can deploy. And we can use front-end deployment. We can use a service, both our ingress or load balancer here. And back-end service, we can use cluster IP for internal. And coming to the database point of view, if DB is running on pod as a pod, so MySQL image you can take and deploy a DB pod. So backend pod, DB pod communicate through service if DB pod count is 0. Clear now? No confusions here. Cluster IP can send traffic directly to the pod only. If one pod only there, this is the condition. If multiple pods are there, so definitely if you can use the cluster IP, request will go here or here, here or here. So backend DB communication, if you use a service as a communicator, this service can send traffic to 0 or 1. Clear now? So definitely we have to manage the state here. So writer request will go to 0, and if required, reader request will go to readers. In this case here, the communication is not service to many. Communication is one-to-one here. And in this case, we can use headless service. Headless service, DNS resolution we can use. Headless, for example, name I'm giving here. MySQL.connector. This is connector. Host is equal to MySQL 0. Here MySQL is the service name. This is default DNS name. So if the workspace name is different, you can give the different workspace name here. Okay. So in this case, if DB on pod, if you are going to deploy in your project, DB on pod, if DB replicas are more 0, 1, 2, 3, first we have to understand deployment.yaml is not suitable if multiple replicas are there. The reason here we can use deployment.yaml also. Reader, writer, everything single pod only. Even pod delete, pod create, everything single pod only. So service can redirecting into single pod only. We don't have any problem. But when we can use here headless and stateful set, if replica count is more than 0, in that case, definitely we have to manage the state, reader and writer. So in this case, one-to-one communication is important here. Pod can communicate writer, pod can communicate reader whenever based on the inside the condition, based on the API method. Okay. Okay. Now, again, still if you deploy a DB on pod, still stateful set and headless, again, we will get many challenges, right? In terms of security, in terms of high availability, in terms of stability and all. It's too difficult to get it in DB on pod. Even DB on EC2 also, we ignored, right? Even EC2 will get somewhere some benefits will get in EC2. Directly EBS we can directly increase. Okay, OS kind of patchings and all we can directly connect and do it. And backup scalability somewhat is easy EC2 also. But DB on pod is too difficult to write a configurations inside. Even if you write a configuration also, as it's a lightweight pod, anytime can delete and create, right? So stability problems will come if DB on pod. So that's what most of the organizations are not using. Application related databases, we are not using any pod. So we can go for RDS. Again, everywhere front and back end is common scenarios, but it is changing here, different. Now, if I take a RDS, we no need to worry about stateful set. No need to worry about headless, right or not? Backend directly connect RDS host. If all are in same VPC, internally will connect server and RDS. This is one way of approach. And whatever approach is there here, except RDS approach, again we have to take care of what? Volumes also, right or not? If you take RDS, you no need to create any volumes. RDS itself will get a volume, right? Automatic scaling for the volume also. But again, if you can take DB on pod, here also headless we have to take care, stateful set we have to take care, and volumes also mandatory, dynamic volume provisioning. Here also same, volume also mandatory. Here also volume also mandatory. So now when I take RDS, so many dependencies, what are the many dependencies are there, we can easily overcome by replace with RDS. Clear now? So storage and reader concepts, writer concepts, high availability, scalability, backup, flexibility, all activities are very easy in RDS compared to DBM pod or DBM EC2. Okay. Okay. So we can discuss now M install git -y git clone. So yeah, I'm going to clone now my Kubernetes main repository. Okay. Now headless service communication, day 16, you can go here. Same, RDA as we discussed multiple times, SFS. Yeah. Stateful set.oml. If you can go to here, day 16, you can see. Yeah. So this is stateful set.ml. Volume climb template is 10 maybe bytes. Here you can see I'm creating a storage class.ml. Provisioner is EBS. So in this case, what I need to do first, go to the cluster. We have to do add-on concept now. Go to add-on now. Get more add-ons. So EBS driver. Next. So role is required. Create recommended, right? So we have to create recommended means we have to create role. AWS service. EK is already selected. You can give permissions. RBAC concept is there, guys. At the time I'll discuss in detail how to give the permissions and all. This is done. Now select automatically. And next, create. So 8th added now. Let's go and check EBS driver is creating mode now. Wait till complete active. So creating now. Okay, it's active now. Now, so you can deploy here. You can see stateful set.ml inside. I'm creating a two services. Okay, one is cluster IP none means headless. One is I'm not mentioning anything. Which type of service it will create? Cluster IP. And then I'm creating a stateful set. I'm taking a Nginx image. Okay. And also store a class.ml to create a PV. And PV is already mentioned inside the stateful set.ml. So let's go to the stateful set.ml. Replicas are 2. So how many volumes will create? 2 volumes will create. So kubectl apply -f. Okay, see, two services are created. one is for headless service, one is for cluster IP service. kubectl get PV, still creating maybe. Pending kubectl get pods. Go to the cluster again. Node group permissions are there or not, we have to check. Node group role ARN. Permissions are there. And go to cluster level. Role is at admin. Okay. So cluster level also permissions are there. And let's go to the node level. So let's give EKS level permission also. So we can manage everything through Terraform, guys. These permissions and all. We are creating a just default cluster only without giving any permissions. Later we are managing. Okay. We can check now. kubectl get PVC. kubectl describe PVC. Copy, paste. No persistence volume available for the climb to storage. Failed binding. Okay. Let's name a. Okay. So let's go to here. What name I have given here? WW is the climb template metadata. Okay. Let's go to here. Store a class. Name is standard I have given. So here I can change WW or there I can change standard. So let's go to here. Okay, let's give here. WW commit changes. Let's go to here. Git pull kubectl get PVC. Okay. Delete -f. kubectl get sc. kubectl delete sc. So we created already standard name, right? So I'm deleting now. Okay. So it will get PVC. PVC. Copy paste. Okay. So PV also not there. Okay, let's apply now. kubectl apply -f dot. Get pods. kubectl get pvc, describe pvc, paste. Why fail binding? No storage class is set. Okay, let's take the reference before. Yesterday we work on which directory? Volumes, right? Volumes and dynamic date and dynamic volume provision storage class.yml. Okay, this is different. Okay, let's add this. Yeah, provision missing right here. Okay, so eBay storage I can add into the yeah, this is done. And go to sfs.yml. Here I can change. Okay, eBay storage. Okay, let's check over there here. sfs.yml. This is old version. Clear only, right? Let's deploy now. Commit changes. Git pull. Okay, let me delete first. Okay, pod deleted. kubectl get pv. pvc. Copy, paste. Okay, so kubectl get sc. Okay, so let's git pull already done, right? Oh, no, sorry. Yeah, now kubectl apply ifnf. Where I have given stateful set. Here only we can do dynamic volume provision here. Okay, so where exactly? Here only, right? Here only, right? It is taking ww. So let's take here. So here should be same name. So here, which name I'm using? So here also we can use EBS storage. Clear now? Let's verify. Volume mount name and metadata name both should be same. Yeah. Commit changes. Again git pull. Let's try now directly. Git pull. Okay. Let's check now. I haven't applied, huh? Okay. Git pull already done, right? Okay. So kubectl apply hyphen. What about PVC? Okay, apply. Okay, my apply failed right before. Okay, clear now? Why still? kubectl describe PVC. No persistence volume available for the client. kubectl delete hyphen f dot. CD day 16. Okay, let's try one more time. CD day 10. Dynamic volume provision, right? Okay, kubectl get PVC. Let's delete first this PVC. Okay, get SC. Okay, let's apply now. kubectl apply hyphen f dot visfs.ml. Which line it is? 22. Set number. Inset. Okay. Okay. kubectl get bots. So this is working fine, right? Okay. Yeah. Container is creating. Container is creating. Okay. So after create container, so volume also will bound. Okay. So first 0 is creating EBS storage. Let's wait for, yeah, first container is creating successfully and second is creating, container is creating. Then what's the difference in there, here and there then? This is the one actually. I'm trying a wrong one. This is the one. Okay. Squalene. Maybe. Service. Okay. So clear. Let me switch to day 13 now. So I'm going to delete this. Okay. I just tried. So EBS is working fine, right? EBS and issue is not there. So I'm going to delete now. Okay. LS. So kubectl get PV. Okay. Get PVC. Okay. Quickly we can delete PVC also. Copy. Can I give multiple? It's not taking. Already deleted. Huh? This is the one. Copy, paste. Let's try to give one also here. I'm not sure it's deleted. Oh, one. Okay, sorry. Delete. Okay. 1, 0. Kubectl get PVC. Okay, nothing is there. Let's go for PV also. Yeah. So whenever PVs are deleted, automatically PVs are deleted. So process is delete process. If you give return process, PV should be there. Now if I can go and check EBS volumes also deleted. Go to EBS volumes here. Clear na? Only 30 GB, 20 GB is only there. My volumes are not there. Okay. Okay, so let's move to our actual process now. Given wrong one actually before. LS CD day 13 stateful headless. Okay, guys. So understand here first. So here we have a config map secrets already yesterday we discussed, right? You can stateful set.yml inside MySQL image is there. I'm going to deploy. Here I'm using which service? Cluster IP none. So along with this deployment, headless service one create. Clear now? And next here you can see pv.yml. So pvc.yml. I'm using which type of volumes it is? Host path, right? I'm not using dynamic volumes in this case, or you can use dynamic volume also. Just we can add storage class.yml here. And next is what? Cluster IP.yml. So this is creating a cluster IP service. Clear now? Okay, and leave it for the backend.py, backend.pod and all. So first this 4 creating what here? 2 services, one sfs.yml and pvpvc also. Okay, and let's go to the backend pod so we can discuss later with this area. Let's go to now apply. So kubectl apply -f. Whenever I can give -f, this 3 will be ignored. These are all will be created. So PV, PVC, secrets, stateful set.yml, cluster IP.yml. So one SFS and 2 services. Clear now? Including volumes, kubectl get pods. So container is creating MySQL 0. So this case is this one, guys. I'm discussing use cases, this one. Okay. So this is already, you know, right? Just you can create one service on a MySQL only. I mean, I'm using combination, this one and this one. Okay. So if I use cluster IP, how the request will go? If I use the headless service, how the request will go? Yeah. Hmm. So, okay, 0, 1, total 2 pods are creating. 0 is a master, 1 is a read replica by default. Okay, anyway. So my end, kubectl get PVC. So yeah, volume climb bound here, kubectl get PV also you can see. Okay, PV also there. Okay. Now, what I'm going to do now, I'm going to deploy one backend pod now. Just for example, backend pod is trying to connect a database by using headless service, by using normal service. Okay, let's give a try. In this case, backend.aml. So this backend pod, you need to understand this one. Clear now? This is the backend pod is trying to connect the database. So this is no need to discuss. This is already, you know, right? As service automatically connect. Okay, through service. Okay. Let's go to now backend pod.aml. Here you can see my end backend pod is there. Now I'm taking a sample backend pod. So busybox image I'm taking for to test. So after that I can log in and I'll try to ping. I'll try to run NS lookup commands. I'll get only the background endpoints only. Okay. Yeah. Let's run this command now. Copy. So paste here. Just consider this is normal backend pod. Kubectl apply -f backend. Kubectl get pods. See, DNS client is working, right? You can understand this is backend. How to log in? Kubectl exec -it pod, copy, paste. Here you can give bin bash. Kubectl exec-it. Correct only, right command? Pod not found. DNS client. What's the problem? Okay, okay. Got it, got it. So I'm taking, okay. Let's try -sh here. This is not supporting maybe bin bash pod not found. Get pods. DNS client kubectl exec-it DNS client. Okay. Hyphen sh also bin bash also. Okay. Okay. Bin bash directory is not there. Maybe dependencies here. I can give. Okay. I'm instead of no. So no need to give pod here. I'm instead of no pod inside, right? Now backend is trying to communicate now MySQL database pod through service, without service. Okay. Yeah. Now you can open one more duplicate tab here. You can check total services names. Yeah. Sudo su hyphen. So guys, kubectl get svc. I can see two service names here, right? So cluster IP none means this is headless. So headless service name is what? MySQL. So this is cluster IP service. Cluster IP service name is MySQL cluster IP. Okay. So I have already logged in right here. If I give NS lookup MySQL, what is the service name? Cluster IP. Okay. Now you can see, guys, whenever I can give MySQL cluster IP NS lookup, so request is redirecting to where? This is what? This address is what? You can check here. 172.20.163.27. Clear or not? So whenever if I give NS lookup command, NS lookup, if I give MySQL cluster IP, service name, this is redirecting to where? Service IP. Right or not? Service IP endpoint. The service IP endpoint redirecting to where? The service IP redirecting to where? Okay. Let's go to check here. kubectl. How to describe service? Copy, paste. See, service IP redirecting to where? Database endpoints. This is 0. This is 1. So request will go to service IP. Service IP redirecting into which endpoint? Any one of endpoint, right? So if I use cluster IP, that is redirecting into any one of the endpoint again. Same like a load balancer, right? So in this case, we cannot define here request go to 0 and 1. We cannot control in the service, right or not? Cluster IP service or load balance service. So whenever we can run NS lookup service name, in that case, if you use any cluster IP service or load balancer service or node port service, the backend request will go to any one of the pod. Clear or not? Any one of the pod. Same example if I take here, NS lookup, see, BusyBox is just if you want to debug anything in the Kubernetes, we can use lightweight image only. Okay. NS lookup, I'm taking now. Second service. Second service is what? kubectl get SVC. This service I'm taking now. Cluster IP none means what? Headless, right? Okay. NS lookup MySQL service name. Now you can see. See here. Total how many IPs are there, Mayan? See, this is directly redirecting into your endpoints, not through service, right? Now, if I use this, request will go to this pod only in the backend inside. If I use this, request will go to inside only the backend inside. So in the backend, how we have to define? Let's go to here, for example. This is my backend.py. Okay. Now you can see. Yeah. Here headless, here I'm giving directly MySQL 1. And this is what? Yeah, this is what? MySQL here, service name. Understand? See, let me show you the process.document here so that you can understand. You can see here, pod name, headless service name, namespace, direct svc.cluster local. Here my namespace is what? Default. And the service name is what? MySQL. Headless service name, I'm giving a MySQL. And pod name is what? MySQL 0. So now if I use this in my backend.py inside, see, if MySQL 0, if I give, the request will go to directly MySQL 0 pod only. For that, yeah, for that here, my service is playing a very important role. My service is what here? Yeah, let's see here. My service is headless service. For example, if you use cluster IP service, this is example is what? Cluster IP service. Cluster IP service MySQL 1. So MySQL.connector, MySQL.1 default SPC cluster.local. So this cluster IP service redirecting into any one of the pod. We don't know. I mean here by using cluster IP service, we cannot mention like a particular pod. Understand? But we can mention particular pod if you use headless service. That's what the difference is. So we cannot write like this. For example, copy. See this, an example. In the backend pod inside, we cannot write like this. Like this. When you use the cluster IP, we don't have any apply the filter to go MySQL 1 only. Clear now? So if you use this, the cluster IP service request redirecting into 0 or 1. We are not sure. But when we can particular pod we can call in place if you use headless service. This is little advanced services, guys. You can clear na? Headless service. Whenever you can use headless service only, we can pick a particular pod for the backend connection. Clear na? Let's go to here. You can check now kubectl describe SVC. Yeah, see these two endpoints are what here? Your MySQL endpoints. So when we can call particular pod here, understand my see these two endpoints attached to which service? Let me show you here. Let me show you here clear way. Okay, let's see here. These are my two endpoints of databases, right? One is MySQL 0, one is MySQL 1. MySQL 0, one is for MySQL 1. Understanding purpose, I'm writing like this. Clear now? Focus now, everyone. This is important for any certification if you want to plan. Okay. This is two endpoints, right? Now here you can see, if you use service here, for example, cluster IP. Clear na? If you use cluster IP here, and this is your backend pod. So in this case, the backend pod when connect a cluster IP, the request will go to any one of the pod. Clear na? The same example, if I take here, now you can see headless service also connected to two endpoints only. But the difference is what here? You can call a specific endpoint by using a headless service. Okay. So whenever you can use headless, so you can write here in the pod inside, we can write here same like to call something. Yeah. So this is the process. Pod name, copy here. For a headless, we can write in the backend code inside like this. Clear na? In this case, pod name is what here? Which pod you want to connect? You can write in the backend code endpoint inside. And which service it is? My headless service name. Just I can mention headless service. Leave it for the name, maybe confusing here. Headless service. Next is what? default namespace. Okay. And default dot. You can give dot here actually. Default namespace dot svc dot cluster dot local. Like this, we have to mention the backend code inside. But this only provision is possible when you use the headless service only. Clear now? Yeah. Same command if you can use here. In the backend pod instead cluster IP. Whenever here you can use cluster IP service. This will take any one of the pod. We cannot control here. Request will go to only MySQL 0. So this is not possible. When you want to call a specific pod, you have to use headless service backend to DB. Here, name is important or not? No. MySQL 0. In the backend pod inside, we can add a conditions. In the developers, right, they can write a code. If it is a read replica, I mean get request, get API, request will go to read replica. If you put API or post API, request will go to write API. In this case, write API redirecting into write database, read API redirecting into read replica. In this case here, we have to mention the stateful set. See here, if it is a put, request will go to pod. If it is a read, request will go to something different. Like this, we can mention because of I'm using here also headless service, here also headless service. So different conditions. Stateful set can call pod 1, stateful set can call pod 0 also. See here, cursor command I'm using to call the request from the pod 1, cursor command request to call the request from pod 0. So independent, we can call the direct pods. So here we can write some logic, get API go to reader, write API go to writer. Yeah. Like this, we can write. Okay. So now this naming is very important, right or not here? So the naming process is very important. Now tell me, that's what we are using. If pods are replicas are 2, which deployment we can use? Stateful set ML. The reason naming order is very important. Stateful set will give pod which name is what? MySQL 0, 1, 2, 3, 4 like that. Now 0 deleted, again create 0. Any communication break here? Backend to DB, no communication break. Same volume will fetch, same data will be there, right? And again create a MySQL 0, backend again immediately will be connected MySQL 0 without any issues. Same MySQL 1 delete, MySQL 1 only will create. Again, no problem. Clear na? Okay. So in this case, if I take deployment.yaml, when we can take deployment.yaml instead of stateful set.yaml, my pod is only 1. Then at that case, you can use this process. No need to give here MySQL 0. Cluster IP dot default service dot cluster IP dot. We can give this cluster IP can redirecting into any one of the pod, the background. So that will be connected. The reason only my end is only one pod is only there. So your cluster IP always redirecting into this pod only. That's what the use case of this one. So we can use cluster IP deployment. When you can use a multiple pods, definitely you can use service this is not cluster IP. You can use headless service. This is not correct. Okay. You can use this one. So we no need to much focus this area. Just what you can understand the reason we are using RDS in the real time. So we no need to worry about stateful set volumes, headless service. But if any monitoring setup, if you can do the monitoring setup by default will get a database also the background, right? For example, Elasticsearch, okay. EFK stack is there. Okay, Elasticsearch, Fluentbit, and Kibana. So this kind of process, Elasticsearch is a database where we can store the data. In this case, this database No, we are not supposed to take RDS, right? For monitoring automatically, it will take inbuilt. At that time, this Elasticsearch deploy as a stateful set. Clear na in the background. So this is little complex one. Any questions from anyone now? So now tell me, there is in the monitoring system, Elasticsearch is there, na? Elasticsearch is a database, right? EFK stack, ELK stacks are there, right? So Kibana logs can be stored into Elasticsearch. From there only we can call. So Elasticsearch as a database here, for example. In this case, Elasticsearch we can deploy stateful set or deployment. So depends on if you use the number of replicas, you can use. Yeah. So this is, for example, EFK stack. Okay. Click on it here. So here Elasticsearch is what here? Database. Why demand set I'm using here? Fluentbit is a agent. Fluentbit install into all nodes, right? To collect the metrics, that's what daemon set. Daemon set is what? Each pod on each node. So here, which process is running as a daemon set? Fluentbit process. Fluentbit is just agent only. Node exporter agent is there na, for the monitoring. So node exporter can install into all the nodes as a daemon set. So collect all the metrics, nodes and pods also. So this is Fluentbit. Fluentbit we are using daemon set. And coming to Elasticsearch is what? Database kind of store the logs. Definitely we can use stateful set. Which service we can use here? Headless. If it is a Elasticsearch having a multiple replicas. This is what display Kibana. For example, I'm not going to deploy now. You can see here EBS storage. See, Elasticsearch set a process. See, I'm using stateful set. Why? Elasticsearch, I'm taking image is Elasticsearch image, directly database. How many replicas are there? 3. Definitely we can use which service here? Yeah, headless service. So that's what is headless service. See, cluster IP equal to none. Why cluster IP none? Elasticsearch deployed as a stateful set. So even we are not deploying any application in the database, we are not taking Debian, but we are using RDS. But some configurations using stateful set also in the background. These kind of approaches are coming. We are not supposed to do anything, but still we can understand, right? See, Elasticsearch where we can, any database monitoring setups we are coming here, we can deploy anything here, okay? So Kibana dashboard here to deploy Kibana dashboard. Clear now? Like this we are using. See, Kibana are using which port here? Node port. Which type of service? Node port. So why Kibana is a external access dashboard, right? We can take here load balancer also like this. So Fluentbit also is a Fluentbit they are taking as a daemon set. Clear na? Fluentbit we are deploying as a daemon set. Like this we can take. Even we are not deploying any applications on Debian part, but this kind of approaches will come. We have to focus. Okay. Any questions from anyone? Any questions? Stateful set. If you ignore this concept as we are using RDS, for example, but this concept we are unable to understand right now, EFK stack. We are not using RDS to store the logs, Elasticsearch inbuilt activity. So kind of things. Yeah. Any questions? Online or offline, both? RDS only always. So Debian EC to Debian pod is not recommended. This kind of approaches only we are using Debian pod, logs monitorings, logs configurations, not for application or main application. For this process, we need a volumes also, right? This stateful set creating for Elasticsearch, right? We are not taking RDS. Definite Elasticsearch, we need a volume. Additional volume we have to provide. In this case, store class is required. EBS ESA driver is required. That's what you can see here. That's what we are using here. See, EBS ESA driver. At the time, add-on options are not available. EBS ESA driver to install. So that's what we have installed EBS ESA driver by using Helm charts. Now we can modify this document. So by seeing this is little complex one, guys. In Kubernetes EFK stack process, this process we can easily do by using OpenShift. You remember or not, at the time we have already done, right? So the complexity, whatever the complexity process are there, they have easily, the OpenShift is released as a, on top of the Kubernetes, they have implemented some layers to give easy process, this kind of things and all. Now you can see EFK stack. Let me show you, for example, to deploy EFK stack, what and all required. Okay. This is first layer where we can collect the logs. This is Elasticsearch where we can store the logs. This is Kibana where we can display the logs. Clear now? For example, from the Kibana, if you want to pull the logs from the last 1 month, last 2 months, somewhere the log should be stored, right? It's a Elasticsearch. So now by seeing this concept, see, we learn in Kubernetes many concepts. Those concepts will come now. For example, Elasticsearch, Kibana, Fluentbit, right? So here one concept is pending. The RBAC process I'll discuss at the time. This is cluster we can create by using YAML file also, like this. Okay. So cluster administrated access, first EBS access, cluster administrated access I have given right before. We can do through Terraform also this process. Next is what we have to give the dynamic volume provision. Already we know what is dynamic volume provision for the database. So this is also no. Next, create namespace. Already we have discussed what is namespace. Create storage class named EBS storage. Already discussed storage class also. Set up Elasticsearch. So I'm going to create a database. So definitely database creating on stateful set if replicas are more than 1. So whenever stateful set you are creating replicas more than 1, definitely this stateful set use headless service. See, that's what is headless service. I'm using headless service also here. Cluster IP none. Clear now? And next is what? So okay, Elasticsearch part is done. Next is what? Kibana, where we can display. Kibana, yeah. Kibana I'm deploying as a deployment only. This is not database. It's a stateless function, right? It's a UI. So you can deploy Kibana image. So directly with volumes are required or not? Kibana not required volumes, right? So leave it. Kibana service, which service we can use? Any service, load balancer or node port. Why? It's a user interface, right? Yeah. Next, Fluentbit. So Elasticsearch completed, Kibana completed. Source is what? Fluentbit. Fluentbit can deploy in which process? It's an agent, right? Deployment or stateful set or daemon set? Daemon set to take all the nodes matrix, right? So I'm going through. You can see. Yeah, guys, you can ignore this RBAC process and all. I'll discuss plural set not supporting this service account and all. I'll take one personal account. I'll explain this concept. Okay. So I'm deploying Fluentbit into daemon set now. You can see. So now this Fluentbit will communicate to where? Elasticsearch. So that's what env variables for what here? Elasticsearch. Clear now? Kibana access. That's it. See, 90% already discussed right everything. So only the pending is RBAC. That also I can discuss. So if you are able to build a EFK stack in Kubernetes, definitely most of the Kubernetes concepts you are aware of this. Understand? So if leave it, you don't try now. This RBAC process is pending, right? Okay, try. If you get any error, you can post into the Telegram group. I'll help you. Otherwise, you can leave it. I'll take care. Let me share this Medium block to you. Wherever EBS ESA driver install process is there, you can ignore it. The EBS ESA driver process, we can go with add-on process. Already we have it, right? Okay. So Monday class I'll discuss RBAC and Tuesday I will discuss service account. These two are very important for the Kubernetes point of view. Okay. So any questions from anyone? Cluster autoscaler, anyone had to complete? Cluster autoscaler. Anyone had to complete? Then everyone completed, right? Nice then. Okay, so no questions, sir. Then complete. Monday. So practice stateful set day 13. You can let me delete this. This is old one actually. Okay, so day 13, you can practice stateful set headless. The AML file there inside the backend pod. This AML file you can copy paste and practice. Let me add the command here. NS lookup. Test both the service headless and cluster IP and observe the how traffic is routing. Okay, thank you. Bye.